So it says that a particle P of mass 5 kg is held at rest in equilibrium on a rough inclined plane by a horizontal force of 10. So here we go, and here is a rough inclined plane. So just to make it clear, when it's rough, this means there must be some sort of friction happening towards the ground. So we can call this coefficient friction mu. Okay, that is the value between 0 and 1, relating how much friction there is. Now, what do we know? The plane is inclined to horizontal at an angle of alpha, where tan alpha is 3/4. So we need to relate some triangle using the usual trigonometry, where we got alpha here, and we got 3/4. So opposite over adjacent equals tan. And using Pythagoras, you'll eventually get 5 here as well. So we can just work with this in a second. Now the line of action of the force lies in the vertical plane containing P, and the line of greatest slope of the plane. Okay, cool. Now the coefficient of friction between P and the plane is mu. Given that P is on the point of sliding down the plane, so if it's sliding down, meaning there's some friction behind it this way. So this is the friction value F, where we can say that at limiting equilibrium, F is pretty much less than or equal mu r. That's how we write it. Or, just to make our life easy, for the sake of question, the maximum value F is equal to mu times r. So the coefficient of friction times the reaction of the plane, where the reaction is always perpendicular to the plane itself. Okay? And one more thing that we need to add. Yes, we need to add the particle P of mass 5 kg. So this is going vertically downwards, and it's 5g. So this is completely down, yeah? Okay, and here we go. So now all we need to do is pretty much label our angles. This will make resolving this so much easier. So I always follow the direction of, let's say, the reaction itself. So if I was to extend this line, I could say that the weight is at an angle of alpha. Okay? And if we're looking at what else, the force is completely perpendicular, so that's good. Now the push, the 10 newtons, if we just extend the line, because if you extend the force, it's the same force. We can see that it's perfectly, horizontal. So just making an incline, we can say that this is an angle. If we just tilt ahead and follow this line here, this is at an angle of 90 minus alpha. Because if you think about it, this is perfectly perpendicular to each other. Alpha plus 90 minus alpha will give us a nice clean right angle. So towards this line, the south line, it will be 90 minus alpha. And is that it? Yeah, I think that's really it. So how about we go ahead and start resolving now. So firstly, resolving towards the reaction itself, we should get R, and that's the only upward force. Now the downward forces, we have 5g cos alpha, and this one 10 newtons. So write 10 here. It will be 10 cos 90 minus alpha. So it'll be, let's do it here. So it'll be minus 5g cos alpha. So the reason why I'm using cos is that this is the method I use. Every time I'm following towards the downward force, I use cos. That's why I always aim towards the downward one. And this would be minus 10 cos 90 minus alpha. And all of this, I believe, should equal 0. One thing to note now is that when you have cos 90 minus alpha, there's a cool property, and you should just memorize this, is that 90 minus alpha is identical to sine alpha. Why? Because if you think of the sine and cosine graphs, 90 and cos and sine are just 90 degrees apart. So it makes sense that the difference between 90 will give this other version, sine. And we know these values, cos and sine, because we have the triangle, the trigonometric triangle, the right angle one. So looking at cos is simply adjacent over the hypotenuse. So the adjacent here would be 4 and hypotenuse is 5. So this value here is 4/5. You could find alpha, but this is more accurate. And sine would just be the opposite over the hypotenuse. So it would be 3/5. That's an easy way to calculate it. So that's done. You probably already know this, but just to be sure. So solving this completely, we can say now that R equals, so throwing everything to the right side and simplifying this, you got 5g times 4/5 is just 4g, so it'll be 4g here, plus, and 10 times 3/5, so cancel the 5s, you get 2, and you should get 6, so 4g plus 6. So that should total to 4 times 9.8 plus 6. Let me have a look. 10 times 3/5. and you should get 45.2 newtons. So that's the value of the reaction. Okay, not bad. Now let's go ahead and resolve towards F, yeah? So let's see what else we can also resolve towards F. And if we do that, what do we have? So we've got F perfectly done. Now let's find the angle behind it. So if we have to extend this dotted line, and let me change to blue. Extend towards the dotted line here. We can see that the angle here would be 90 minus alpha, because you can just complete this triangle here. This is 90 minus alpha. And what else do we have? That's a 5G line. Now the 10 newtons, we can just, is going towards the same direction as F. So that would be angle of alpha, which is the same as this angle here. And R is perpendicular, so we don't include that. And that's it. So we've got F and 10, which are positive, and we've got 5G, which is on the negative side. So we can say F plus 10 cos alpha. So F plus 10 cos alpha. And on the negative side, we're going to have minus 5G cos 90 minus alpha. So 5G, and 90 minus alpha is just sine alpha, equals 0. Alright, not bad. Now just make F the subject here. So we're going to have 5G sine alpha minus 10 cos alpha. So just throw everything on the right side. And record that F is this UR. And we know what R is 45.2. So it'll be 45.2 times mu equals all of these. So 5G, so we can go ahead and just smash this in the calculator. And I got 21.4 newtons. And now finally just dividing 45.2 across, and you should get 0.473 for the coefficient of friction.